There we go. All right. So 8.1 is about similarity and ratios and proportions. So the things we want to be able to do today are find similarity ratios and write similarity statements. Similarity in general will kind of remind us a little bit uh, of triangle congruence, and when we talked about naming congruent triangles and things like that. So similarity is going to go fairly similar to that. So go ahead and grab your notes and let's get started. And come on, camera, catch up. There we go. Okay, so 8.1, better lighting there. All right, similarity and ratios. Okay. So when we talk about two shapes being similar to one another, it's kind of like if you remember back to when we did dilation in first quarter, the shapes that we dilated were similar to the original shape. So it's basically what happens if you take something and preserve the dimensions or I guess preserve the ratios of the dimensions and expand it or contract it. So kind of like that analogy that we used back then, where you take the corner of something and like if you got a picture in a Google Doc or something and you drag the corner to make it bigger or smaller, it's still the same picture and it still keeps all the same proportions. It's just larger or smaller. That's what we mean when we talk about similarity. So, for example, if I had some similar triangles here, maybe we have triangle ABC and a larger triangle DEF. So if I were to say that these two triangles are similar, first off, the notation triangle ABC is similar to triangle DEF. It's like you took the congruent symbol and got rid of the equal sign. So it's just that little squiggly. That's the technical name for it. That is the similarity symbol. Okay. And so what that tells us is that angle A is congruent to angle D. The letter order still matters, just like it did when we were talking triangle congruence. And the first part of it is going to look a lot like triangle congruence because the angles still match up and are congruent. The angles are all preserved. So angle A is congruent to angle D because they're both the first letter. Angle B is congruent to angle E because they're both the middle letter. And then angle C is congruent to angle F because they're both the last letter. So far, we have the same thing going on as we did with congruence. So if we were labeling the picture, we'd label A and D are the same, B and E are the same, C and F are the same. But that's where the sameness stops. That's where the congruence stops. So it means this, and it also means something for the sides. But it doesn't mean that the sides are going to be congruent. AB is clearly not congruent to DE. This one's definitely longer than this one, but they do have the same ratio. So what we mean by that is if I put AB over DE, that's going to be the same as BC over EF, which is going to be the same as AC over DF. So I take the sides that would match with one another when we're talking congruence, and I put them in a ratio. And those ratios will all be the same. If we were thinking of this in terms of dilation, this ratio would be the scale factor. Okay. So, oops, drop the pen. Um, what this concept, it's the same ratio. And this ratio has a name, it's called the similarity ratio. Okay. So there's a couple different things that we want to be able to do with similarity ratios today. The first thing we want to be able to do is find a similarity ratio given two shapes that are similar to one another. All right, so first example, we're going to be told that PQRS is similar to DEFG. And notice for similarity, it's not always going to be triangles that we're working with. Sometimes we'll be working with four-sided shapes and five-sided shapes. There's all kinds of polygons that you can use with similarity. The most common ones you'll see will be three and four-sided shapes, but occasionally you'll see polygons with more sides that we talk similarity for. So PQRS is going to be a rectangle, and that's a very blobby looking rectangle, but oh well. PQRS, and we're told that one side is 25 units and the other side is 10. And then we have DEFG, which is also a rectangle. And DE is 2, and DG is 5. And we want to, the instruction will be like, find the similarity ratio of PQRS to DEFG. All right, I'll give everyone a moment to write that down, and then we'll talk about it. And if you've got it written down, and you start thinking about what you think the similarity ratio might be, maybe write down a guess on your paper. Okay. So if we're going PQRS to DEFG, what we need to do is find one of these ratios of side lengths where we have a side from PQRS over a side from DEFG, because PQRS comes first. So if I'm looking PQRS to DEFG, the side on PQRS has to go on top. So in this case, I might use PQ. And then what side does PQ go with on DEFG? Based on letter order, which side from PQR or from DEFG goes with PQ? So PQ are the first two letters. Yeah, it's close between DG and DE, right? Those are the two kind of tempting ones. It is DE though, because D and E are the first two letters. So first two letters goes with first two letters. Second two letters goes with second two letters. First and last letter goes with first and last letter. Okay. So PQ over DE, and then we know that PQ is 10 and that DE is 2. So 10 divided by 2 is 5, and that would be our similarity ratio for PQRS to DEFG. Okay. You could also use PS and DG if you wanted to. Really what we're looking for is one of these ratios that we know both side lengths for. So I'm looking for two sides that match up where I know both of their side lengths. Okay. Or we could also be asked for the similarity ratio of DEFG to PQRS. And that would be different just because DEFG coming first means that the side from DEFG has to go on top. So we would go DE over PQ instead, which would be 2 over 10, which reduces to 1/5. Okay. So that's how we can have two different similarity ratios. It depends on which shape comes first in the order of what you've been asked for. Okay. So now that we've seen this one, I'm going to have you guys try one real quick. And then we'll talk about it. So we're starting off with triangle SRT is similar to triangle MLN. Oops, you guys can't quite see all of that. Move that up. This side will be 5. This one is 10. 2 and 4. And we want to find the similarity ratio of, first we'll find triangle SRT to MLN, and then MLN to SRT. Okay, so go ahead and give those a try. When you think you've got it, type "got it" in the chat. And we'll talk about it then. It is MLN. Because that's what we were given up here. Yeah. Sorry, I know this side doesn't quite look like half of this one, and this definitely doesn't look like half of these, but go based off of the numbers and the letters, not what it looks like for this one. And it's okay to get fractions here. All right, let's talk about this one. So we have SRT to MLN. So we can always just pick a side to start with from SRT. Anyone have a particular side length you'd like to start with? Sure, we can start with SR. So SR, what does SR go with from MLN? ML. Yeah, because that's the first two letters and the first two letters. So we know that SR is 2 and that ML is 5. So that is our answer here, 2/5. That's a fraction that doesn't reduce any further. So then to go the other way around, to do MLN to SRT, we would just put ML on top and SR on the bottom. And we'd get 5/2, which is also a fraction that doesn't reduce. And when you see on your homework today, they'll ask you to reduce the fraction, but if it's an improper fraction, you can leave it like that. It's okay. You don't have to write 2.5. All right. So that's one thing that we're going to want to be able to do today. Find the similarity ratios. Let me double check. I'll go try one real quick and see if it takes it. Nope, you got to use the fraction. Yeah, so you're going to want to use the fraction and make sure you reduce your fraction and stuff like that. Good question. It will not accept decimals today. Okay. The other thing that we want to be able to do is actually look at two shapes that are similar and write a similarity statement to go with them, which is going to look a lot like what we did with, again, with congruent triangles and stuff like that. It's going to rely a lot on, at least for triangles and stuff like that, knowing which angles are the same. But you can also do it just by knowing which sides go together and whatnot. Although that's a little bit more difficult. Okay. So let's give that a go. Writing similarity statements. Okay, so the simplest case you'll see will be dealing with triangles where you know all of the angle measures. And in this case, as always, letter order matters. You'll see with some quadrilaterals like rectangles and stuff like that, there could be multiple correct answers. But especially with triangles, you're really only going to get one letter order for each like starting letter order that you get. So what we mean by that is if we have a couple of triangles here, 57 degrees, 63 degrees, 60 degrees. We might have something like that and be asked to finish the similarity statement. Triangle LAP is similar to triangle blank. Okay. So what we would want to do then, just like with triangle congruence, is match up the angles that go together. So for example, since we started with angle L was 57 degrees. Angle R is 57 degrees over here, so R would come first. If A comes next, what letter comes next from this triangle? U. Yeah, because A is 63 degrees and U is 63 degrees. And then last, by process of elimination, N would come next. So triangle LAP is similar to triangle RUN. Okay, so that's one kind of similarity statement writing problem that you're going to see. Another one is going to be the case where you have a quadrilateral. Maybe you've got a rectangle going here. And it's a little harder when you've got a rectangle because you know all the corners are the same. So this one will require a little bit of working with the sides and a little bit of eyeballing things. We might be asked to finish the similarity statement, ARHS is similar to blank. Okay, so this is one where there's actually a couple different possible correct answers. Because on a rectangle, you have two short sides and two long sides. So the long sides, you could have that OL goes with AS, or you could have that OL goes with RH. Depends on just how you choose to label everything. So this is where we could have a couple of correct answers. But starting here, we've got AR. AR goes along one of the short sides. So we want to pick a short side combo from this rectangle. So maybe I pick ON. Once I've picked my first short side combo, though, if I'm going in this direction, I have to continue in that direction. So if I go from O to N, then I have to continue and go ML. So we want to pair a short side with a short side to start. You could have also started, though, with LM and gone LMNO, or you could have gone MLON. There's a lot of different combinations when you're dealing with a rectangle that will actually fit and work with your rectangle with the first statement here. So there's a lot more correct answers when it comes to rectangles, which is kind of nice and freeing. But those are kind of the two main types of problems that you're going to see where you're asked to write a similarity statement. We could have one where there's more sides involved. We could have something like this. And we might be asked to write the similarity. Oops, I had two P's in there. We'll make that an R. Oh, we already had an R. Just kidding. This will be an O. Goodness, that's the problem when you have too many angles in your picture. You run out of letters. All right. So we could be asked to write a similarity statement for PSTRA. What is that similar to? So then looking at this picture, we can go, okay, well, it went from P. We started at P that has one arc in the corner. But over here, we have two different ones with one arc in the corner. So we have to figure out which one actually goes with P. And we can figure it out if we figure out what the first two letters are, P and S. It goes from one arc to two arcs. So over here, it's going to have to be N and M because this is the only scenario where you can go from one arc to two in order. So we would say N, M, and then you can just kind of continue around the shape, L, Q, O. Okay. So that's probably, I mean, you're not going to see too many like this, but you will see a lot that are like the first two. Okay. So off of any of these examples, are there any questions, any numbers or letters we're not sure where they came from? Any letter orders we're not 100% convinced of? Okay. So these are pretty much the main types of problems that you're going to see today on your IXL sections. We've got figuring out similarity ratios and then writing similarity statements. So I'm going to go ahead and post those, and then we will talk about them, take a look real quick together, and move on to where you get to work independently. All right, you might have to refresh your Google Classroom page if you would like to see the assignments. We're doing IXL P1 and P2 to a SMART score of 80. So the first one, P1, is all about similarity, or sorry, this is P, it's all about similarity statements, and then P1 is all about similarity ratios. So it'll ask questions like, what is the similarity ratio of triangle IJK to triangle BDC? So you take a side from IJK, and you take the matching side from BDC and put them into a ratio. It says you can use a proper fraction, an improper fraction, or a whole number, but no decimals. So, for example, on this one, I might pick IK. I and K are the first and last letter. B and C are the first and last letter. So it would be IK over BC, which would be 1/3. And yes, you only have to go to 80. If you would like to go to more than 80, you are welcome to, but you only have to go to 80. And on a lot of these, it's kind of nice. You can eyeball what's supposed to go together. Like on a rectangle, on two rectangles, it's very clear which side is the longer side and which side is the shorter side. And spoiler alert, long sides go together and short sides go together. So if I'm doing STUV to CDEF, I can take the short side here over the short side here and get 1/4. Look at that, we're already up to a SMART score of 36. Okay. Sometimes you'll see things like trapezoids, where you might want to start using letter order if you can't just eyeball it. On this one, ST goes with CB, so you can go 1/3. Things like that. Okay, so that's that first IXL section. The second one tells you that the two polygons are similar, and you need to complete the similarity statement. So this one goes BCDE. So it starts off with BC going along a long side. So over here, we would want to also start off going along one of the long sides. So you could go WXUV if you want to. And here in the triangle, then we've got all of the angles in the picture. And so if it starts off with X, Y, Z, then we could start and go like H, G, F or something like that, because H goes with X, G goes with Y, F goes with Z. Okay, so all of these are going to, or a lot of these are going to look like this. Any questions before we get going? Okay, then you guys are free to use the rest of the period to work on your own. If you have questions, feel free to stick around. If you need help with anything, please stick around. Otherwise, have a wonderful rest of your day.